Hi everybody, we're working on 1-2, isolating variable. Last time we were together we did order of operations, we worked on using that, which was a big review. Isolating variable is also a review, but I've also discovered that sometimes it's a topic that students don't really understand completely from Algebra 1. It's also important for those of you that are juniors, that are in chemistry, very important. For people in physics as well too, because we start to work on formula, and that's going to be 1-3, but being able to isolate a variable is important for our math and for science math. Couple of definitions, and if you want you can pause this video as you're watching it outside the classroom to talk about a variable. What a variable is, a quantity that may change within the context of a problem or experiment, and there's our science. So a variable is something that changes. If the weather is going to be variable today, it might be cloudy in the morning, sunny at noon, and rainy at night. Variable, things change. To isolate, to get something by itself. If I'm going to isolate you, I'm going to put you by yourself for some reason. If I'm going to isolate the variable, we're looking to get it by itself. So these two definitions I'd like you to have in your notes. So if you need to pause and write down, please do that. The next part says isolate X. If I tell you to isolate X, it also means to solve for X. So this part in orange can go in that next part. Isolating X means to solve for X too, meaning we're going to find out what X equals in that case. Okay, so that's the first part. Now let's start going into some examples. So, the first example I have is D equals RT. You may remember this from middle school or Algebra 1. Distance equals rate times time. I've got that in italics. And then you can fill in the blanks. D is equal to distance that the object traveled. R is equal to the rate that it traveled, the speed, the velocity. Sometimes you may see D equals V times T, especially in physics. And then T is the time it traveled. So everything changes, okay? And in this case, we're solving for D. We want to know what D is equal to. Well, it's equal to the rate times time. If it's going 100 miles an hour for 1 hour, 100 times 1 is equal to the distance, 100 miles. Okay, and we'll work on solving them next time too. But it's to isolate the variable, get D by itself. And that one's kind of easy because it's given to you that way. What's the next part say? It says solve for R. So isolate R. And this becomes our work right now, everybody, okay? So this is kind of an important part right here. It sets the tone. D equals RT. We're solving for D, that's the formula. But what if you were given D, and what if you were given T, and it says solve for R? Isolate R. Get R by itself, solve for it. It's joined by multiplication. So we divide both sides by T to get rid of the T. And you guys probably remember this from balancing equations, solving for R. T divided by T cancels. So R is equal to distance over time. So if we don't know how fast it was going, but we know how far it traveled and we know the time it took, we can figure out the speed. Miles per hour, meters per second, centimeters per hour, things like that, okay? So, that's solving for R. Now I've got kind of a general statement that I'm gonna put up. And the general statement for number 2 says, whatever operation is happening, do the opposite. I am going to post this on the Google Classroom so that you can write these into your notes from there. I'm not going to take the time to write out number 2 right now. Please check the Google Classroom or a friend or something like that to be able to write that statement down. It's just too long for me to take. But number 3, it talks about opposite operations. Well, you know that plus and minus are opposite, right? If it's got addition, then you subtract. If it's got subtraction, then add. Multiply and divide are opposite. There's different ways to show that though. Sometimes the dot for multiplication and the divide sign, like A divided by B. Sometimes for multiplication, we have parentheses next to each other like that. That also indicates a multiplication. If we have AB, that indicates multiplication. So all of these indicate multiplication. Okay? What's another form of opposites? Well, squaring something and rooting something. Those are opposites too. So let's do a couple here in the time that we have. Number 4 has D equals 1 over P. And it says we're solving for D, that's what we have, but solve for P, isolate P. How do we do that? Well, we can times both sides by P, because P's in the denominator. We don't want it in the denominator. That cancels, so we have P times D equals 1. And I hope you're writing this down. Again, pause the video if you need to pause it. We still don't have P isolated, but since it's joined by multiplication, we can divide to get rid of it, the D, on that side. And there's our answer. We've isolated P, we've gotten P by itself. Okay? So that's important for that one. Another one that you know from geometry, and you remember from geometry a lot, and maybe even middle school, is the area of a circle is equal to pi times the radius squared. When I used to sign people's casts, when they'd come in with a cast or something, I'd always sign it pi r squared. I don't know, that was always my signature. Here we're trying to find the area when we know the radius. Square the radius, times it by pi. But what if we know the area and we want to find the radius? Isolate r. What are the strategies? Well, divide by pi. So a over pi equals r squared. That cancels. What's the opposite of squaring? And I gave you that in the notes. And we have a fire alarm, so I need to stop.